Hello. Today you're going to learn about the ratios of area and volume in similar figures. So we'll talk about what that means. At this point, you should have completed the baby mama and papa investigation. Now I'm going to just go over it with you in with sample numbers. So here's my baby rectangle in green, the mama's in red, and the papa's in black. Let's find the perimeter area and volume of each. And then we're going to look at the ratios. So the perimeter of the baby is 5, 10, 11, 12, 13, 14. The area is 5 times 2 is 10. And the volume, remember, it has a height of 1 for the baby. So 5 times 2 is 10 times 1 is 10. The perimeter of the mama is 1028. The area is 40. And the volume, remember, it has a height of 2 now, so it's coming off the page with a height of 2. So 10 times 4 is 40, times 2 is 80. Whoops, the volume of the first one was 10. Okay, so you have 10 and then 80. Now let's look at the papa. So perimeter is 1530 plus 12 is 42. The area is 15 times 6, so 30, 60, 90. And the volume, remember, has a height of 3, 270. So now what we're interested in is the ratio now of the areas and the volumes. And the perimeters. We'll look at the perimeters too. So we know that the mama, every side has a 2-to-1 ratio, right? The mama to the baby is 2-to-1. The papa to the baby is 3-to-1. All right? So now let's look at the perimeters. So the mama to the baby, it's twice as much. So it's 2-to-1 for the perimeter. And then the papa to the baby is 3-to-1. All right, so the perimeter has the same ratio as the side ratios between similar figures. So these are similar three-dimensional solids. Now the area, so now look, mama to baby is 40-10, which is a 4-to-1 ratio. And then papa to baby is a 9-to-1 ratio. All right, keep that in mind. So 4-to-1, 9-to-1. And now let's look at the volume ratio. So mama to baby is an 8-to-1 ratio. And then the papa to the baby, 27-to-1 ratio. The next page, I have this all in a chart, okay? So this is baby to mama, perimeter, 1-to-2, same as the side. So perimeter and side ratios, also known as scale factor, is the same. But now the areas, look at it, 1-to-4 or 4-to-1 ratio, 1-to-9 ratio, 4-to-9. How do these compare? Or, how do those compare? They're squared. Look, 2/3 squared is a 4-to-9 ratio. 1/3 squared, 1/9 ratio. Okay, now what about to the volume? How do the volume ratios compare? Look, they're cubed. 2/3 to the third power is 8 over 27. It's the cube of the ratio. So that's how that works. So the area ratio is equal to the side ratio or the perimeter ratio squared, and the volume ratio is equal to the side ratio to the third power. So this works for all three-dimensional figures. So here we go. I'm going to do a bunch of examples for how this will help you solve some problems. So if the ratios of sides of two similar trapezoids are 5 to 7, calculate the ratio of the areas. So the side ratio is 5 to 7. So the area ratio is squared, 25 to 49 ratio. The ratios of edges of two similar pyramids are 8 to 10. Calculate the ratio of the volumes. So you don't need to know the volume formula for pyramids, but you can figure out the ratios. So here we're going to cube it. So it's 8 to the third, which is 512, over 10 to the third, 1,000. And then if the ratio of the volumes of two similar prisms is 27 to 64, calculate the ratio of the edges. So now how would we work backwards? So what's the inverse of cubing? Cube root. So then the cube root of 27 is 3. The cube root of 64 is 4. So it's a 3 to 4 ratio. All right. And then let's say we wanted to know the area. Didn't ask for it, but what if I said find the area ratio? 9 to 16. You square the 3 to the 4. All right, so here's some more examples. Each pair of figures is similar. Find the similarity ratio of the figure on the left to the figure on the right. Then find the ratio of surface areas and the ratio of volumes. Okay, so let's see. Find corresponding parts. Okay, 4 to 36. The 8 to 72 would give you the same ratio. Let's simplify it. Let's see, divided by 4 is 1/9. So it's a 1 to 9 ratio from left to right. So the area will be squared, 1 over 81. And the volume will be cubed. Whoops. 1 over 729. Okay, and now these other examples we're going to do, we'll be able to find actual surface areas and volumes of figures. So now the similarity ratio between two similar figures is given. The surface area and volume of the smaller figure are given. Find the surface area and volume of the larger figure. So we have a 1 to 5 ratio for sides. Well, let's get the area ratio then. That would be squared. So it's a 1 to 25 ratio. We know the smaller surface area. So now you solve the proportion. So we have 25 times 76 is 1,900 centimeters squared. Now let's do the volume ratio. So that's 1/5 to the third, which is 1 over 125. 144 is the smaller volume. So now the volume of the larger figure is 18,000 centimeters cubed. See? So you don't even need to know the formulas for the volume, which we will learn at the end of the year. You just use the ratios to find them. Okay, let's do this next one. Okay, so 5 to 8. You could even pause the video, try it, and then check. So 5 to 8. So let's get the area ratio, 25 to 64. Okay, they told you the 425 is the smaller. Okay, so 64 times 425 divided by 25 is 1088 centimeters squared. Now the volume, the cube ratio, so it's 125 to 512, and then 3375 over x. 13,824 centimeters cubed. And 2 more problems. Some information about the surface area and volume of 2 similar solids has been given. Find the missing value. So, you are given the surface areas. So that's a 64 to 784 area ratio. We need to get the volume ratio. So you have to first find the side ratio, or the side ratio. So to go backwards, you take the square root. So the square root of 64 is 8. And the square root of 784 is 28. So it's an 8 to 28 ratio. Now we need the volume ratio. So that's the cube of the side ratio. 512 over 21,952. So that's what we're going to use. So we want to know the larger volume. So now cross multiply. 9,604 cubic feet. All right, let's come over to here. This time we know the volume, so it's 1728 to 8. Okay. Which actually simplifies to 216 over 1. So this is the volume ratio. Now let's go to the side, because you have to cube root of 216. And if you forget how to do it, you go to math. Number 4 is cube root. 216 is 6. So it's a 6 to 1 ratio. So the surface area, or the area ratio, is squared 36 to 1. All right. So you know solid 1, the bigger one, is 576. So we'll put the x with the 1, cross multiply. 16 square centimeters. So there you go. So that should help you out with your homework. So you have the link in Google Classroom for the Go Formative assignment. Go ahead and do that. As always, email or come to the extra help session if you have any questions. Have a great day. Take care.